Alright, in this lesson we're going to be focusing on how to use Table F in our solubility unit. And this is going to allow us to figure out which substances are soluble or insoluble. And it allows us to predict if a precipitate will form from a double replacement reaction. And precipitate is simply a solid product, which allows us to see that a double replacement reaction has actually occurred. So a precipitate will form if one or both of the products listed is insoluble. So right now we're not going to focus on these double replacement reactions. We'll do that in a lab. We're solely going to focus on determining is something soluble or insoluble using Table F. So you might want to pause and just read through how to use Table F. I'm going to be following these steps. I'm not going to take the time to read them to you. You can do that on your own. I'm just going to walk you through them with these examples. So with number 1, we have potassium nitrate. In this case, you can find both parts of this on Table F, but I always start with the negative ion, which in this case is NO3 nitrate. So you can see I circled it here. Nitrate is over under column 1. And you can see I'm going to be talking about column 1, 2, 3, and 4. These aren't on your Table F, but you can see where I'm talking about. So since nitrate has no exceptions in column 2, I'm going to stay in column 1. And if I look up at the top, nitrate is an ion that forms a soluble compound. So I can label potassium nitrate as being soluble, and if it's soluble, after the formula we would want it to include an AQ there, meaning that it does mix in with water. It is soluble. If I have calcium carbonate, I'm going to look for carbonate on the chart, and I'm going to find it over on the right-hand side, CO3. I'm going to check to see if it's combined with a group 1 ion, which would be potassium, lithium, and that group. However, calcium is in group 2, so it doesn't apply, and neither does the fact that it would be bonded with ammonium. So I'm going to stay under column 3. If I look up at the heading, I see that it's labeled as insoluble. And if it's insoluble, we actually put it as an S as the notation following the formula. So this S does not mean soluble, it means that it is a solid, which makes sense of why it's insoluble. It's not going to dissolve into water, so it will stay a solid or a precipitate if it's being formed in a double replacement reaction. Alright, I changed this one up. You need to make sure that magnesium sulfate is now lead sulfate. Okay, so the reason why I did this was because I want to make sure we do an exception over on the left-hand side. So sulfate is over here under column 1. However, lead does fall under column 2 as an exception. So column 1 means that it's soluble. If it is an exception, that means that it is insoluble. So we again include the S as a solid for the lead sulfate. Alright, and then here we have ammonium hydroxide. I can find hydroxide over on the right-hand side. Hydroxide is normally an insoluble, or will form an insoluble compound. However, ammonium, NH4, is under column 4, which makes an exception to hydroxide. Since column 3 was insoluble, the exceptions mean that they have become soluble. So we'd use again AQ after ammonium hydroxide to indicate that. One little note to make sure you know about the wording of some Regents questions is sometimes they'll use the phrase most concentrated or least concentrated. When you see that, think about solubility. If something is the most concentrated solution, you're looking for the one soluble compound. If it's least concentrated, then you're going to look for the one choice that is an insoluble compound. So just a little thing to kind of keep track of when you're doing multiple choice questions. Okay, you should be all set with using Table F for this solubility unit.